Hello, in this video we're going to be solving systems of equations. So a system of equations is when you have two or more equations and you actually have to solve for two or more variables. So a set of two or more equations is called a system of equations, and we're going to solve these in two different methods. First we're going to tackle the substitution method, and then we're going to tackle them by the multiplication addition method. And so you'll very quickly see what I mean by systems of equations compared to what we've been doing before. These are the steps that we're going to be following for the first method, the substitution method, and you can always refer to this if you get lost along the way. So in example 1 here, you'll see that we actually have two sets of equations. We have a first equation and a second equation. And this is what we mean by systems of equations. Notice we have an x and a y. So we have two variables, and we have two equations. And this is a good thing. If we have two variables and two equations, we can solve it. Usually we say two equations, two unknowns. Three equations, we need three unknowns, or vice versa. So this is the basic idea. Before I go any further, I just want to change this answer here. There's a little typo in the little solution I gave you. It's actually supposed to be 3 and -1. So how are we going to tackle this? We've got lots of stuff going on. Well, there's two methods, like I said, substitution or multiplication addition. Let's try substitution. First step for substitution says to solve one equation for one of the unknowns. In this case, if we look at these two equations, this first one is actually quite easy to solve for one of the unknowns because x doesn't have a coefficient. So I'm going to go ahead and go down here and solve this one for x. If I bring the y to the other side, like a regular constant would do, now I've transposed this equation for x only. Okay, that's going to get me somewhere. That's the first step done. The second step is to substitute the resulting expression into the other equation. So I've done step 1. Second step, I'm going to substitute the resulting expression into the other equation, the equation I haven't used yet. That's this one. So I'm going to go ahead and say 2x plus 3y equals 3. And I know that x is this, so I can replace it here. 2 times 6 plus 3y plus 3y equals 3. So I've substituted the resulting expression into the other equation. Now I need to solve this equation for the unknown. I need to solve it for whatever's still left, which is in this case is the y. So you can fast forward this if you don't want to watch me go through this. Multiply through 12, 6y, 3y equals 3. I'm going to group all the variables on the left, make 9y, and then bring my constant to the right side. That gives -9. And divide both sides by 9. And this gives me y equals -1. And I'm going to put a nice strong box around that because I've now fully solved for it. So what do we do next? We solve this equation for the unknown. Substitute this value into one of the original equations. Sorry, I'm just tidying this up. Substitute this value into one of the original equations. So I can take this one, or I can take this one. It doesn't matter. Whichever one it seems like would be easier to get y out of. In fact, I'm not going to use either of these, even though it says the original equations. I'm going to use this because x is already solved for. So why would I use the original equation? So it is kind of the original equation, it's just been rearranged. So I'm going to say x equals 6 plus 3y, and again I'm using this because it's already solved for x. You could happily use these and solve it for x. It's going to be the exact same thing. And what this gives is 3 times y being -1. X must then be equal to 6 minus 3, or in other words, x is 3. So I'll just do a quick color code here, just so you can see that this y was taken and put down into this equation, which is also from this equation. Take a moment to make sense of that. But in the end, we ended up solving for x and y, which is the whole point. Did I do everything? Substitute the value into the original? Yeah, and check my answer. I didn't check my answer, but I'll do a quick check. I'm not always going to do the check, but in this case, I will. I'm just going to take the first equation at the top of the page, and I'm going to put my numbers in just to make sure it equals to 6. So that means that's 3 minus 3, which is 3 plus 3, which is 6. Okay, so it does match out. So you can always check your answer by putting your solved solutions, your x and y, back into the original. Example 2, substitution method. Well, this is a little bit different this time because we have word problems, but nothing we can't handle. Let's zoom in a little bit here. It says, a landscaping company placed 2 orders with a nursery, so a nursery of trees. The first order was for 13 bushes and 4 trees, totaling 487. The second order was for 6 bushes and 2 trees, totaling 232. What were the costs of 1 bush and of 1 tree? So let's take this in parts. I'm going to break that first sentence into equations. If we have 13 bushes and 4 trees and they total 487, that means we have 13 times the cost of 1 bush plus 4 times the cost of a tree. That equals $487. The second order, 6 bushes, 2 trees. That means we have 6 times the cost of a bush times 2 times the cost of a tree is 232. So now we have, once again, 2 equations, 2 unknowns. And that's a good thing. We have the same number of equations as unknowns. That means we can solve it. Okay? So step 1 is to solve one equation for the unknown. Well, this one's a little trickier. It's not obvious which one we should choose. And in fact, any of these would work. What I mean is you could solve for this b, you could solve for this t, you could solve for this b, you could solve for this t, and often to figure out which one would be best often only comes from experience. But I like to start with small constants in front of our letters, which divide evenly into the right side. So what I mean is, this 2 in front of the t, if we were to solve for it, just thinking ahead, I would move this over there. I see that this is a multiple of 2. If I were to divide everything, the 232 would be nicely divided by 2, the 6 would be nicely divided by 2, and I'd leave just the t. So I can see ahead of time that my best choice to solve for is this t right here in the second equation. You don't need to start there. You can go and try solving for any of the variables. You'll still get the final answer, okay? But I just know from experience that that is the best way to go. So I'm going to go ahead and I'm going to try to solve for this particular t right here. So I'm going to solve that equation. 6b plus 2t equals 232. And again, just jump forward if you don't need to watch me do this. Solving for the t, so moving everything else to the other side. Notice there's a 2. If I divide this by 2, I need to divide the whole right side by 2. And some of you might be rusty with how that works. So what it means is, if you have one term on bottom, take each term on top, divide them each by the 2. All right? And keep the sign that was between them. And now simplify that. T equals 132 divided by 2 is, I should probably know this. I could use a calculator to double check. 116, and then 6b over 2 leaves the 3 on top, so it's minus 3b. Okay, that's important. I'm not going to put like a nice black box over that, but I'm going to keep note of it because it's important. I've solved one as a function of the other variable, b. So I've solved one equation for one of the unknowns. I'm going to substitute the resulting expression into the other equation. So this is extremely important. I've used this second equation already. I'm not allowed to just put it back in to that equation that I used because it wouldn't work. You can try it yourself and see that it actually doesn't work. I need to take this letter t and I need to use the first equation because I haven't used that one yet. Okay, that's why it means into the other equation. That's what it means by other. So I'm going to go ahead and do that. Just let me keep track. This would be my first step. My second step would be to write down the other equation that I haven't used yet. And once again, I'm going to color code the t's here so you can see where my head is. And now I have 13b plus 4 times our t, and we know that t is 116 minus 3b equals 487. And now I've got only b left to solve for. Once again, you can fast forward, jump forward if you don't want to watch me solve this. All right, there we go. On the left side, I've got 13 b's minus 12 b's, so that leaves me a single b. On the right side, I'm going to have 487 minus 464. That's 23. And it just kind of pops right out. I don't need to do a division because the coefficient in front of b was just fine. It worked out to be 1b. All right, so I've got 23. So let's see my steps. Substitute the resulting expression. I did that. Solve the equation for the unknown. I did that. Substitute the value into one of the original equations. So once again, you can take this b, you can put it into this equation as b, you can put it into this equation as b, or you can put it into this equation as b. I like to put it into the equation that's already solved for t because it's less work for me. But again, it doesn't matter. You can put it into any of the three equations. It makes zero difference. Okay, so t is 116 minus 3b. And I know what b is. 116 minus 3b. Once again, if you wanted to, for example, see it clearly, I could call this b purple. And now I'm just replacing it with what we know it is, 23. And see what this works out to. That's 116 minus, what's 3 times 23? 3 times 23 is 69. And then we go 116 minus that, which would be 47. And now we finally solved for the cost of one bush and one tree. The cost of a bush is $23, and the cost of a tree is $47. And that kind of makes sense. The bushes should be cheaper than trees, generally speaking. And we could go back and put, for example, 23 in for this here. We could put 47 in for this t here, and we should get 487 when you work that out. All right, so that's how we do the substitution method. I'm going to move on. We're going to do the multiplication addition method next. But if you need a little bit of extra help with the substitution method, of course, this might be something that you haven't seen in a while if you are not coming straight from high school. These are practice problems. You can check your work. This should be the answer you get for the first one. This should be the answer you get for the second one. And these are similar to the ones that you'd find on D2L, if not exactly the same. There's a video that you can watch. The link is here. You can click on it in the PDF and you'll go right there, or just type in this address and you should be able to find it, no problem. It's about 9 minutes, but it'll review this entire thing. It's a really good Khan Academy video. The second and last method we're going to cover is the multiplication addition method. And as the title says, we're going to be doing a multiply and then we're going to be doing an addition. There's another word for this. It's also called the elimination method. That's the standard word for it if you were to find it online. But the multiplication addition method, the reason we call it that is because the process involves a multiplication and it involves an addition. And I'll go through these steps in context as we go. So let's see what makes this method different than the substitution method. Solve the following system by multiplication addition. Well, it sure looks the same. I mean, the questions look exactly the same as what we've been doing before. So if you don't know the difference between the methods, you might be tempted to use the substitution. But let me show you why multiplication is useful. First of all, step 1, if you can read this, it says place both equations in the same form. So something x plus something y equals a constant, something x plus something y equals a constant. Okay, they're in the same form. We've got that step done. Next, if necessary, multiply one or both of the equations by a constant to obtain coefficients that vary only in the sign. Okay, this is what makes the multiplication addition method called the multiplication addition method. Look at this here. For example, you have a 6x and you have a 2x. You have a 4y and you have a negative 3y. You have a negative 8 and a 193. Just follow me here. 6 and 2. They are different by a multiple of negative 3. What I mean by that is if you have 2 and you want to make it into a 6, all you need to do is multiply it by negative 3, correct? 2 times negative 3 is 6. And why that's important is if we were to take the entire second row here and multiply it by negative 3, what it will do is it'll allow us to cancel out the x values very easily. So just bear with me here. I'm going to take the top and rewrite it. Nothing's changed there. But the bottom, I'm going to take every single term and multiply it by -3. Okay? So another way of writing this would be to, on the left side, think of it as having a -3 multiplied by it. And on the right side, we have a 193. Think of that also as having a -3 multiplied by it. Okay? But I like to write it all in one line. So 2x times -3 is -6x. -3y times -3 is +y. And 193 times -3 is -579. Now I need to make a note. That is actually a typo. So this 3 was not supposed to be there. I just wanted to show you what would have happened if you went through the way that I went through it the first time when I looked at this. That's not supposed to be there. It's actually supposed to be a 19, and a 19 times -3 is -57. So let's just put on the brakes for a second, remind you why we're doing what we did. Okay, these equations here, what we noticed is that it was easy to make this 2x into 6x by multiplying it by -3. So this 2x turned into this -6x. But you're probably still asking, why the heck am I doing this in the first place? Well, this is the magic of the multiplication addition. We've multiplied. Now we can just add, okay? Add column method, use column addition, which means top to bottom. Add top to bottom and see what happens. We have 6x minus 6x. Go column by column. 6x minus 6x gives 0 x's. So actually we don't have anything. It canceled all the x's. So the x's canceled. That's a great thing. That means that it's going to leave only y's. So we have 4y plus 9y. That would be 13y. And then -8 plus -57 would be -65. And now look what we have. We have 13y equals -65. So just divide both sides by -13 and you got this. Or by 13, not -13. I think it's at -13. Alrighty. Y equals 65 divided by 13 is 5. So -5. Okay? So we have multiplication. That's this one. I guess I should have made it blue. Multiplication is this step here. The addition that we did is when we added these together using column addition, okay? I'm going to take out the highlighting, but you can try to make sense of that yourself. So let's go through our list. If necessary, multiply by a number, yep. Add the revised equations together. This should eliminate one of the variables, yes. Solve for the remaining variable. Ooh, do we have this? Yeah, oh yeah, we got the remaining variable. That's the y, the one that was left over, that didn't cancel. Now we have to substitute this value into one of the original equations. So take the first equation or take the second equation. It really makes no difference. I'm just going to take the first equation. So you're going to sub y into the first equation. Let me be crystal clear here. It does not matter which one you sub into. It makes no difference. It'll work both ways. I'm just choosing the first one because it's the first one I see. So 6x plus 4y is -8. So I'm going to replace the y with what I know it is. It's -5. That means that 6x equals -8 plus 20. That means, 6x equals 12. That means that x must equal 2. And there we have it. We have our x equals 2, and we have our -5 is our y. Cool. All right. Let's double check, substitute, all good, check my answer. All right, if I really need to, if this is a test or something, you might want to know that your answer is right. So I'm just going to check, see if it works out. I'm going to take the second equation and just check to see that it equals to 19. Does it equal 19? 2 times x, 2 times 2, 3y is -3 times -5, and that minus 3 times -5. That indeed does equal 19. So it checks out. It's no problem. So hopefully now that I've done this, maybe if you've done it before, you remember it. If you haven't done it before, you've learned something new. It's called multiplication addition because of this second step. Multiply one or both of the equations by a constant to obtain coefficients that vary only in sign. for one of the variables. So I multiplied a 2 by a -3 so that it gave us a -6, which I could cancel out with the top of the 6. And I could have done the exact same thing with the y's. They already were different in sign. So I could have said, for example, I could have multiplied the top by 3, and it would have given a 12y. I multiplied the top by, I could have multiplied the bottom by 4, and it would have given a -12y for this I'm talking about. And it would have worked out the same. But generally speaking, we're going to keep these fairly simple and only have to multiply one of the equations, if we can help it. Let's try one more example. Solve the following problem by multiplication addition. This problem looks familiar. So it's the exact same situation as we had before. So we have 13 bushes and 4 trees is 487. We have 6 bushes and 2 trees, that gives 232. And it wants us to solve it by multiplication addition, so that's the big difference. And that shouldn't be too bad. Let's just try and think about what our steps are. The first step is to make sure they're in the same form, which they are. And if necessary, then we need to multiply one or both of the equations by a constant to attain coefficients that vary only by the sign. So you can pause the video and try to figure out which constant you're going to use to multiply by one of these equations. But just because I want to save some time, I'm going to notice here that we have 4t and 2t. It'd be super easy to make that bottom equation equal to the top, right? These are not the same sign, so I need to do something about that. But I'm going to be focusing on t to cancel out, because 13 and 6, for example, are quite different from each other. It's hard to make them equal. You'd have to multiply top and bottom. In this case, we only need to multiply the bottom. So to make myself clear here, if I take the whole bottom, multiply it by -2, that will turn this into a -4, which will then eventually cancel out with the top and bottom. But let me show you. I'll just move it over to the right and rewrite them. The top equation has not been manipulated in any way, so I'm going to rewrite it. The bottom equation, on the other hand, everything has been multiplied by -2. So 6b turns into -12b, because 6 times -2. We have 2t minus -2 is -4t. And now we have 232 times -2 is -464. This is our multiplication step. We've finished our multiplication step. Now we add top and bottom. 13b minus 12, or 13b plus -12, same thing. It leaves us a single b, or just b. 4t's minus t. 4t minus t cancels out. We're left with nothing. So you can say here plus 0 t's, but generally if you have no t's, you don't want to write it. It's just going to muddy up your workspace. So this actually ends up being 23, 487 minus 464, and I'm going to rewrite it next to each other. b equals 23. I've solved for one of my variables. What do I do next? I go back to one of my original equations and sub it in. I'm just going to go ahead and choose 13b plus 4t, because it's the first equation over here that I see. I'm just going to go ahead and put it in there. So you can, again, move forward if you know what I'm doing. All I'm doing is substituting in, but I like you to see where it all comes from. On the left side, I'm going to keep t. On the right side, I'm going to do 47 minus 13 times 23, which should leave me with 188. I'm going to divide both sides by 4, and that would leave me with 47. So it's clear here that I've got my 23, I've got my 47. So my answer is correct. I've done multiplication and addition to get that. To be clear here, some students ask, what about if I had used the second equation? You know, this equation looks a little easier. It doesn't have this weird 13. The numbers are a bit smaller. Can't I use that? Of course you can. It doesn't make any difference whatsoever. So I'll write this out instead. I knew, at this point, I only knew b. So 23 plus 2 times t equals 232. That would mean 2t equals 232 minus 6 times 23, which is 94. And then 10 sorry, 2t equals 94. 94 divided by 2 is 47. Exactly the same. Exactly the same. It doesn't matter. There's multiple ways to do this. So the more of these problems you do, the more practice you get, the more you realize you can do it multiple ways. As long as you're still doing multiplication addition when you're asked to do multiplication addition, there is choice along the way. For example, if you really wanted 13 and 6 to cancel, well, let me think. You'd have to think, okay, 13 times 2 is 26. That's not a multiple of 6. 13 times 3 is 39. That's not a multiple of 6. 13 times 4 is 52. Is that a multiple of 6? No. I think 13 times 6 would have to be it, which would be 78. So you'd have to take the bottom, you'd have to multiply the top by 6, and you'd actually have to take the bottom and multiply it by 13. You have to multiply it by negative 13 in order to match these constants and coefficients. It's just not worth it. So go back and try to make sense of why I chose the numbers that I did, and I think you'll be okay. The last thing to do would be the check. So for example, I'll check my final answer over here in this dream sequence here. I'm just going to take the first thing, 13b plus 4t equals 47. We're trying to figure out if it's going to actually equal 487. 13 times 23 plus 4 times 47. That should equal 487. And 13 times 23 plus 4 times 47 is indeed 487 if you check that on the calculator. All right, so that's pretty much it. That's how we do these methods. You should have plenty of examples now. The time for you now has come to practice. So you want to do these two questions, answers are given, do them by multiplication addition, and see what you get. If you have any trouble, of course, make a note of the questions that you have trouble with, and I'm happy to go through any of them during class. There is, once again, another review video. This one's 12 minutes long because it's a little more involved. There's more explanations. But if you are having trouble at all, please follow this link. It's a really good explanation of how to do this. And finally, there's one extra practice problem that you can try yourself, similar to the trees and bushes question. So I'll just write that here. And the answers are given. You can check your work. And once again, there's more practice found on D2L. I just gave you a selection of the problems here in this video, but there's always loads of practice on D2L and different explanations too. So don't forget that you can always go to D2L to get a little more support in the material. And then of course, if you still have issues with this, you come to me and let me know what questions you want answered, and I'll be more than happy to go through any question with you. That's it for today's lesson. Hopefully you learned something today. Hopefully this was clear, and I wish you all the best, and I will talk to you very soon. Bye-bye.